So you were the Elon Musk before Elon Musk, right?
Yeah.
You and the team created the electric car long before it became famous.
You know, South Africa is a small country when you start doing big things.
From aerospace engineering to electric vehicles and radio astronomy, Gerhard Swart's career is anything but ordinary. He worked on the Roy Falk attack helicopter, went on to co-found Optimal Energy and help create the Joule electric car back in 2008. Today, he applies that same systems thinking to the Square Kilometre Array telescope.
What gave you guys the, I don't know if audacity is the right word, to be able to think that you can make a car?
The size of a car is a bit like the Mercedes A-Class, but a bit wider and a bit more upright. We put Panda decals on to try and disguise the shape a little bit. There was such a positive reception at Paris. We were approached by 11 distributors from 32 different countries. We also went to the Geneva Automotive Show.
To develop a car and industrialize it is not a joke.
At that stage, the writing was already on the wall. Maybe I should sort of transition to the sadder part of the story. We trusted our funders, and unfortunately, government appointments make it a bit more like the SABC board or, you know, the ESCOM board.
And that really irks me. It's I think any successful country is based on the ability to go from creation to value creation, not importing it from somewhere else and then thinking that you've created something you haven't.
So I've been in the trenches for the past 20 years, building production lines around the world. On this channel, I share with you my real-world experience for anyone looking to make a real impact in their factory. Whether you're a plant executive, an engineer on the floor, or anyone eager to expand their knowledge on this transformation topic. Let's dive in.
Hi, Gerhard. How are you?
Hey, Anish. All right. And you?
Yeah, good. Nice to see you again.
Yes, likewise. I was watching a podcast of yours earlier, and I just looked a bit at the history of GenderMark, and I was just so impressed by your company, and it was, it's
Thank you.
Good to see.
It's it doesn't come without its challenges, as I'm sure you know.
Sure. Yeah, I'm sure. It's a very nice success story, you know.
Yeah.
I like it.
Thanks. We're very proud of the fact that we're taking African technology and trying to help the world. Obviously, it's typically the other way around.
Yes.
And we're very proud of the fact to fly our flag, and not just to let people know that we've got good wildlife and good meat. We've got some other good things going on.
Yes.
So no, it's great. Thanks for taking time again, and it's certainly a massive honor for me to actually have you here. So Gerhard, thanks again. As I said, it's a massive honor to actually have you on the podcast. I've watched the journey of the Joule. I actually had two very good friends working at Optimal Energy, and we all watched. I remember I was just starting my working for a couple of years. I was still relatively young. Watched Optimal Energy and the Joule progress step by step. I still have a photo of my friend driving the second or third car, or he was in the car while somebody else was driving, and I thought, wow, that is next level. That's amazing. And then obviously there's a tragic story behind the whole thing, which is, I guess, we'll get into that. But to have you here, the guy that was the chief technology officer of Optimal Energy, one of the founders. And I've told a couple of people that I'm going to have you on the show. So you were the Elon Musk before Elon Musk, right? If you look at the timeline, you and the team created the electric car long before it became famous. So that's pretty amazing. And obviously you now work in a completely different technology space, making radio satellites, and we'll get into that. But maybe we could kick off with the story of the Joule. Just talk us through that, and maybe as you weave us through the story, just what made you get into wanting to make an electric car at that point in time? It wasn't a commonplace thing.
Yeah, well, thanks for having me on the show, Janesh, and it's really a great privilege for me as well. And South Africa is a small country when you start doing big things. So, we do run into each other all over the place. So Cobus Myron, who was the founder of Optimal Energy, or the CEO, and I worked together along with a guy called Jan Swiggers and Mike Lomberg. The four of us were working on the SALT telescope at the time in Sutherland. And I mean, that's an amazing project with its own story, a real technology showcase. But at the end of that, we were saying to each other, what next? We'd worked together well, and we were contractors, so we had to do something else now. And Cobus had done a lot of energy-related research, and he said, energy is going to be the next big thing to change. We just come through the whole dot-com bubble, and he said, no, energy is going to really be in short supply, or we're going to have to start using it more efficiently. There were rumors of climate change, but the big thing for me that he pointed out was so-called peak oil, when oil consumption starts going higher than the production of oil. And then you get oil-related wars, you get price spikes. And I mean, this started in the 70s already. We saw these things happening. But about a third of our energy is actually consumed in transport. And it's one of the major things that we felt would have to be completely changed. And the automotive companies at the time seemed completely blasé. They were ignoring this as a potential thing that was coming. We actually didn't start ahead of Tesla. We were probably starting around about the same time. They may have actually started slightly ahead of us. We actually met some of the AC propulsion people that were, sort of the early Tesla.
Is this 2005-ish, right?
That was 2004, 2005. Yes.
Okay.
Yes. And so we realized that the thing that's going to make the difference is batteries. General Motors had made an electric vehicle, I think it was in the 70s, 80s, which they ended up crashing and giving rise to a documentary called Who Killed the Electric Car?
Yeah. Okay.
But that had a lead acid battery. And so when Cobus and I went off to China, and we started looking at what batteries are available, and laptops and cell phones had made such a big impact. And in China, there were major programs to develop large-scale batteries. And then we looked around for high-efficiency electric motors. We couldn't really find any globally, but we then looked at the University of Stellenbosch that was doing very significant electric motor research.
Okay.
And we were wanting to localize as much as we can, especially the expensive items like batteries. So we looked to the University of Western Cape that was doing hydrogen fuel cell research, and we convinced them to get into batteries as well.
Okay.
And then we wanted to partner with automotive people in South Africa, but not the big OEMs, because it would be David and Goliath. And so we spoke to Jimmy Price at High-Tech, and some of the local sort of kit car builders, and then obviously the parts providers and the supply chains for the automotive companies. We put a funding proposal together, and between us and the Innovation Fund, it went back and forth for 18 months.
Wow.
At the end of that, we'd already finished SALT, and we were living off our savings. And so we were very happy when December 2005, finally they said yes, and we formed Optimal Energy.
Wow. What was it in the proposal that triggered the interest in the funding? Was it IDC, right?
No, that was at that stage the Innovation Fund.
Oh, the Innovation Fund. Okay.
Yeah, part of Department of Science and Technology.
Yeah.
They had a category of funding which was for innovation. I think they called it commercialization, but it's sort of taking research that's proven a bit further.
Okay.
And this sort of fit nicely into that segment. It would have been grant funding. That's what they offered, 15 million Rand of grant funding. We thought that would carry us for 3 years.
Yeah.
But when they saw the proposal, they got so excited about the potential, they said they wanted shareholding in the company.
Okay.
So there were lots of strings attached to their money, even from day one. But yeah, it was a good partnership. The people we were working with was a really solid group of people that understood where we wanted to go and were very supportive. So in the first 2 or 3 years, it actually went very well from that perspective.
So in context, I guess back then that was probably just probably over $1 million, right? And for 3 years of funding to develop an electric car,
Yeah.
I think that just in itself shows the innovation in how you're able to convert $1 million into something that you can actually drive at the end of the day. Because if you look at conventional funding, especially out of the US, $1 million doesn't even touch sites. You don't even start anything for
Yeah.
less.
No, it doesn't go far.
Yeah.
And in the end, we actually spent it over 2 years, the first 2 years, because they allowed us to accelerate. But one of their conditions was that we get a second funder on board to give us the next impetus, and that was the IDC. But we did so well that the Department of Science and Technology actually said we will chip in some of the sort of direct government funding into this as well in those very early days. So this is just a very early crowd. So there's Kobus Meyring, Jan Swiegers, and their wives, myself. Mike Lomberg was taking the photos. Unfortunately, he's not in this photo. And this was in our very first office, tiny little office, and our very first employees. And we were just celebrating the move into our first office. And so that was sort of a real entrepreneurial stage where we were doing the dishes and sweeping the floors ourselves.
Wow.
And, just getting going. And this used to be a workshop, furniture workshop, actually. We moved in there.
This is in Cape Town, right?
This is in Cape Town, in Woodstock. Then later on, we met with Keith Helford, which is a story in itself. So his lawyer was also our lawyer, and the lawyer said, "Hey, but I know this automotive designer, and Keith Helford is actually world renowned for his work at Jaguar. He designed the famous XJ220, which was the fastest production car in its time."
Yeah.
Very excited to come and work with us. And that gave us a completely new direction, whereas up to this point, it was very much an engineer's car. And he told us, people buy cars based on their emotions. And we argued with him. And in the end, he won. And I realized, even I, ultimately, it's a car I like.
Yeah.
And that made a difference. And so he made a big difference because he came with that depth of automotive experience as well. And he worked with his ex-boss at Jaguar, Jim Randall. And between them, they helped us actually with the packaging of the first car, the proportions and stuff, because we had all the handbooks and whatever, but we didn't have anyone on the team with real automotive design experience.
And this was the 2005, eh? Or 2006?
This was still in 2005, yes.
Okay. Wow.
So, this was in 2006. So we kicked off January 2006, towards the end of 2006. And then we were busy with our very first prototypes. I actually thought I had a photo of it, but I don't. And what we did at that stage is we made a technology prototype and a exterior prototype.
Okay.
So the technology prototype was just a platform where we were testing our concepts for what the vehicle chassis should be and the drive system and the batteries. And we had an aluminium wafer with the batteries inside, like a so-called skateboard.
Yeah.
And we tested in-wheel motors with a front electric motor and different telemetry systems, but it was open. And I just had a roll bar over the top. And we used that to demonstrate the technologies. And then Keith developed the styling of the car, and we had a guy called Keith Bright here in Cape Town that is absolutely a craftsman. His team made then a model of the car, full-scale model, so that we could actually see what it would look like and whether we like it, and what changes we need to make. And this next photo was the unveiling of that model. This was the end of the second year, to the Department of Science and Technology. This is the Director General of the department. That's Keith Bright, the craftsman, and one of his guys there, Keith Helfet, and then Quibus and some others. So we at that stage had developed a lot of the sort of technical requirements and the engineering architecture and things like that for the car. So it was represented in the looks as well. For example, the black roof was because we wanted actually to put a solar panel in the roof. And that was sort of a styling feature that we wanted represented.
Like what gave you guys the, I don't know if audacity is the right word, but it really is almost that confidence to be able to think that you can make a car?
Yeah, well, Quibus and myself and Mike came from the defense industry, from Denel.
Yeah.
I worked briefly with the two of them as well, but I sort of came more from the weapons side, and they came from the aircraft side. And there you see, from a technical perspective, there's no limit to the complexity that you can actually manage. You just need the right way of going about solving the problem. Yeah. In my book, I have a chapter called Eating the Elephant.
Yeah.
That explains how you approach such a complex problem. And we had done it with aircraft and very complex systems, and how to have a team of 1,000 engineers working on one thing. And we knew that South Africa was good at it. I've worked abroad as well before this, on the Hong Kong International Airport, and worked with engineers from all over the world. And I really take my hat off to South African engineers. They really are so creative and pioneering, and not afraid to go into those places. But they're also a bit more generalist than many other engineers, so they can connect the dots between disciplines even, and so we felt with that skills base, we could do that. And then with the right partners, with the working with people in the automotive industry, with the right technology developers, that we would be able to bring together all of these different aspects, from the technical side, but then also partnering in terms of marketing and logistics and all of those other aspects of the business.
Yeah. Sorry, I interrupted your story as you were going through the pictures.
Oh no, this is good. So by 2008, that's the third year, we had sort of improved that model and had sort of really progressed now a lot with the engineering of a real car. So that would be one where this technology and the shell were actually into one car, which I'll show in a second. But we realized to get more funding support and more, just to start the process of getting the public to recognize there's actually an electric vehicle on its way, we had to somehow go out there and start developing the brand and getting the public support. So we planned to launch the car for the first time to the public at the end of 2008. And we realized at that time, or by that time, that the volumes that we'd be able to sell in South Africa would be small. It would take a long time for us to really penetrate the market sufficiently that we can get economies of scale of a car. Our very first ideas had been almost a delivery van type vehicle, which would be a niche application, and it would not have to look good, and it was okay if it was a bit rough on the edges, and so we could make it quite cheaply. But as we worked with our funders, especially, and from the government side, we realized that there really is an opportunity to penetrate the mainstream automotive market. And so we decided to launch at the Paris Automotive Show, which meant we would be right out there in sunshine, as it were. But before that, we wanted to first honor our South African public and our South African partners and have a local launch, 2 weeks ahead of the Paris Automotive Show. And this photo is from that launch. We had Minister Mangena, who was the Minister for Science and Technology there. And he was an amazing supporter. His whole department, even through to the closure of Optimal Energy, science and technology always understood the challenges of innovation, the potential of innovation and this type of project for the country, and were firm supporters. And they were just outranked with other government departments, and their funding was just not enough to actually go into the industrialization phase. But that's the rest of the story. But at this stage, it was happy days, and we were on our way to Paris, and it was a major thing for us to be out there in the market. Well, not in the market yet, but in the marketplace.
Yeah.
So this is just me and my family at the Paris Show Car in our showroom. So we had quite a string of visitors and potential investors. So a lot of work done in trying to find other investors at this stage. So it was never our intention to be reliant on government completely. So we worked with various sort of big consulting firms like KPMG, PricewaterhouseCoopers, and others to develop our business plans to a sort of a very mature state, to get proper due diligence on them, including all the aspects of a business, OEM business.
Yeah.
And we then contracted PricewaterhouseCoopers with another company called Excelsium to be transaction advisors for the major amount of funding that we require. So at this stage, we, they told us within a year they would be able to put the deal together that we required. And they put deals together for Gautrain to actually fund the Gautrain project, major European satellite programs, for example. So we were talking several billion rand for that industrialization. And they were really confident that we could do that. But as part of that process, we were looking at South African sort of angel investors as well to carry us through up to that point. But then an unfortunate thing happened, and that is the IDC said to us, but we're funding you, and we don't want you to use some of the money we give you to pay this transaction advisor to get another funder. And obviously, we engineers, we're not successful business people like Elon Musk, so we don't have deep pockets that we can fund this sort of thing, on our own. So we were then stuck. And that stopped us from actually getting further funding. So I mean, that's always part of such a journey.
What was the ask? What number did they come up with?
So it evolved a little bit through the process, but in the end, the high confidence number that we had by 2010, 2011, when we were had sort of our full-fledged development plans, there was 9.2 billion rand. That was then for the industrialization, which I'll speak about in a minute, because that's the hard part, and you will know that.
Yep.
But not all the listeners necessarily. Plus then putting up an assembly plant at East London for the car and for the battery system, establishing the supply chain, and then obviously doing all the safety testing and homologation, and then included, I think, the working capital for X years. I forget which number.
Okay.
And that wasn't supposed to be grants. It wasn't supposed to be even all investment. We from working in, with our partners, we realized about a third of that could probably be loans. We were using big industrial companies from Germany to do some of the engineering for us, and the German government would be willing to put some loans in there. A third would be incentives. There were many significant government incentives that would come to play. And a third of that, was really what we were talking about as actual funding. And in comparison, as you will know, the automotive industry was already receiving billions a year from the government in incentives, and also in some forms of subsidies. So it's not actually such a big number considering.
Yeah, to develop a car and industrialize it is not a joke.
Yeah,
and especially batteries. I mean, batteries, you couldn't borrow an engine from somewhere else. You had to develop it from scratch.
Yes. Yeah, so we were planning to import the cells and then put the battery system together, and then later localize the cell manufacture. So yeah, we had sort of firm plans around that. But yeah, so when we got to the second prototype, we felt, to really try and get this middle of the ground, low volume manufacture done cost effectively, we needed to look at how cars were made, how the body was made in particular, because from our research, if you go to sort of monocoque construction, stamped steel, which the industry standard is, you need probably 50,000 a year to break even.
Yeah.
And we needed to cross that threshold. And so we were thinking initially maybe 10 or 20,000 a year, we need to do cost effectively. And so this was just a concept that we evaluated, where you would take laser cut steel so that it's very precise, and you would have sort of indexing points on that, so that it fits together almost like a jigsaw, and then you don't need jigs to actually put the whole thing together. It would be self-jigging.
Wow.
So our mechanical engineers came up with this, and you can see lots of spot welding where the sections came together and went into their little slots. It was not that easy to put together, and I can't remember what thickness of steel they used, but it was quite heavy.
Was that just to get rid of to avoid building a body shop?
Yes.
Okay.
Yes.
Yeah, the fixtures and jigging and stuff in a body shop is expensive.
Yeah. And what you can see here is the battery. We designed it from the ground up, so this wasn't a modification of an existing, petrol or diesel car.
Yeah.
We felt there were several compromises that you would make if you designed a car, or if you, just modified an existing car. And so, like Tesla and some other companies later, we started with a completely clean sheet, and we started with a battery as the heaviest big item, and that would fit under the floor in this compartment. Can't really see it very clearly. Yeah, this is sort of a mudguard there, and there's sort of a 2-module battery pack with ventilation. So this is actually a ventilation duct that would come in from the front through the engine compartment, and then actually go through the battery modules, which would be there, and then exhaust out the back. So you got natural airflow, through the system.
So there was no water cooling in the batteries, I guess.
No water cooling required. Yeah. Our analysis, we chose a battery that actually was a very high performance cell. And interestingly, it performed so well that, even after the Joule was scrapped, 10 years later, they could actually still use those cells and repurpose those cells.
Oh, wow.
in energy storage applications. So,
wow.
Yeah, so our engineers did a good choice there. So that's what that car looked like when it was finished. We had a little test facility outside Cape Town in Atlas Gardens, and next to that was this piece of this unused road. It was an old road that was just fenced off, and we got permission from the farmer to actually test there. And so we did a lot of our initial testing in this space.
Who drove the first one?
I can't actually remember. I think it was probably Kunrad Strijdom. He was one of our sort of early test engineers. I recall seeing him in it, but I don't know exactly who it was. But we put Panda decals on to try and disguise the shape a little bit so that it wasn't that visible.
Yeah.
And of course, it gives it a nice green flavor. But this was before the company was actually launched. This was sort of in that same period of time.
So what year was that photo taken?
So this would have been early 2009, I think.
Okay.
So
it's after the Paris Motor Show.
So this was just after the Paris Automotive Show, yeah.
Okay.
But the whole development and some of the early testing, I think, would have been before that.
Yeah. Wow.
So during 2009, it was a big growth in the company. We, at that stage, received quite a bit of funding from both DST and IDC, I think to the tune of 70 million rand each that they were putting in, with the expectation that we now need to move quickly and come up with a fundable business plan. So the fundable business plan was developed in 2009, plus then get all our partners on board, our partners. Our strategy there was, we will build expertise in optimal energy for the top of the pyramid in every discipline that we need. But then in the detail work, we will only focus on the electric vehicle specific technologies, so batteries and motors and software. So we would develop those own teams in-house, but the actual body and chassis and homologation testing, and then the design of manufacturing plant, logistics, all of that, we would just have a small core team and we would contract the rest out. And so we worked with EDAG in Germany. We'd gone out to various European companies to well, not quite tender, but to get proposals from them for that, and then we settled on them. Very sort of good, solid partnership that we had established there, and with IDIADA in Spain to do the homologation testing, and EDAG would also do the plant design for both the vehicle assembly plant and the battery assembly plant. But we had to find the right people, and this is just the sort of 2009 photo. I think we closed at 62 people, if I'm not mistaken. Someone can count the photo and tell me if I'm wrong, but
yeah.
We were looking for people that were passionate, that were innovative, and then obviously experienced in what they do, but not necessarily in electric vehicles. And we only picked up a handful of people that actually came from the automotive industry. It was a bit easier when it came to logistics and production, but in actual engineering, we only had a handful of people. But our strategy was to make sure, at the very least, that our exco level were people with automotive experience.
Yeah.
So we recruited Diana Blake there next to Kobus. She used to be the general manager of Mini South Africa.
Okay.
And so strong marketing experience. She was our head of marketing. And I think at this stage we had not Mules there yet from the that came on the production side, and Eugene on the supply chain side. And so this is mostly sort of engineer and admin type people. It's probably interesting to say that one of the people came to us just before this growth phase saying, "I want to work for you," and we said, "Sorry, there's no positions." They said, "I'll work for free." Wow. And this guy ended up working, we paid him what we could afford, but essentially for about 3 months on a fairly minimal salary until we actually got enough funding to give to appoint him. And he was a very good engineer. But that's the sort of, I guess, attraction that the project created.
Yeah.
And company created. People they felt the passion and wanted to be part of it. So maybe just for those that don't know that much about cars and electric vehicles in particular, but some of the features. So, in our long-term design, it would have been just a normal monocoque construction. We came to that conclusion at some stage that we have to go full scale. And when we came back from Paris, there was such a positive reception at Paris. We were approached by, I think, 32, no, it was 11 distributors from 32 different countries that wanted the rights to distribute the car.
Wow.
Even just after seeing the model and the spec sheet, that they really felt there was such demand in the market and they wanted this. And but then we made the decision after the Paris Automotive Show that we have to go for the 50,000 quantity and go to a monocoque construction. And so we then started the detailed plans for a real large-scale manufacturing plant. And so that's what's represented here, is what that final car would have looked like. And so we had a charging connector in front, both a Type 2 charger that you could charge at a sort of charging station, but also you could just plug it into your wall socket at home. And for South Africa, we felt that was a real benefit, because if you were living in a city and you were just commuting to work and back, that would have been ample.
Yeah.
And taking 8 hours to fill the battery is not a problem. And that's the cheapest way.
I mean, I take it back then there were not too many DC chargers.
There were none. There was basically nothing in the country. We were working with government and others to try and put some infrastructure in the country, but we'd through the Paris Automotive Show and the research we'd done, realized that Europe was pushing electric vehicles very hard, including the UK. And at this time, there were already 23,000 chargers in the UK, more chargers than electric vehicles.
Really?
Public chargers. And they were paying £5,000 subsidy for anybody that bought an electric car. Wow. So it was absolutely ripe. And so the UK would have been our primary market, driving on the same side of the road as us. So we were, aiming between them and South Africa to try and get close to the 50,000 mark. But also we designed the interior of the car that you could swap left and right quite easily, so that we could go into the rest of Europe. So, that was our primary market. And they had mostly these Type 2 chargers. Later on, DC chargers came in. But at that stage, there were no DC chargers around.
Okay.
So we settled on a sort of a front wheel drive with a central electric motor with this underfloor battery. And in our very first car had 6 seats. We felt that may give us an advantage, but it turned out to be a bit clunky and too niche. So we, then went to a more mainstream design with that.
Where you think of a front bench kind of thing?
Yes. Yeah, so I think it actually had 3 independent seats, and the car was quite wide.
Yeah.
The size of a car is a bit like a Mercedes A-Class.
Yeah.
But a bit wider and a bit more upright. One of our big design drivers was a large boot at the back that you need to fit a washing machine in.
Okay.
So the opening had to be big, and I'll show you a picture in a minute there. So this is just a very nice CAD diagram that we put together just to show some of the parts, which I thought I could flash up there.
Just out of interest, while you're still on the technical stuff, what voltage were you running?
A 380, 400 volts nominally. Okay. So using, basically nominal 380 volt electric system.
Okay.
It was 32 kilowatt hour battery.
Okay.
And the electric power from the motor was about 70 kilowatts. So it wasn't huge.
Yeah, but it
was ample. We didn't try and go for sort of a sports performance, at least not with the first model, because we felt that would, use up your range too much.
Yeah.
So we also went to the Geneva Automotive Show, and this was, taken there. We partnered with a company called Zagato. Many people may know Zagato. They are famous for making absolutely beautiful sports cars or for designing them on behalf of, many others. They've done some Porsches, they've done some Lamborghinis and whatever. But we had partnered with them also on some of the styling, and they were going to be involved in some of the engineering to get the looks of the car absolutely stunning in the very end, in the manufacturing process. But we shared a stand with them at the Geneva Automotive Show, and that was really fantastic.
Parked next to some Lamborghinis.
Yeah, so I don't know I can't remember what that was, but that was, the red one was theirs. And yeah, the show car that we used there, had a fully populated interior plus, under the hood as well. And it was quite tight, but it was part of our design intent was to move away from the conventional automotive design.
Yeah.
We don't have this hot, noisy thing up front anymore. So let's see what opportunities we can get. And so we did try to make it as compact as we can, get, more foot room and all the rest of that.
What's the liquid, the bottle there? There was a bottle in the bonnet there. What liquid was that?
That's for the wiper fluid, I think.
Okay. Oh yeah.
Although it did have a radiator, we the electric motor efficiency is sort of anywhere between 76 and 90%, depending on your conditions that you're driving in. And through all the testing and whatever, it never got probably above 42 degrees. You can put your hand on, and it, most of the time you won't even notice whether it's warm or not. It's sort of body temperature. So yeah, and then we did have power brakes and stuff, so we needed
hydraulics,
sort of those vacuum systems, but they had to be electric, and for the brakes. So this is the interior of the car. You can see a spot of Jaguar there.
Yeah.
From Keith Halford. This is an actual photo. This is not a CAD rendering.
Wow, it's really, really, really nice.
Yeah.
I mean, considering it was 2009-ish, right?
Yes. Yes.
Wow.
So it's probably a bit formal, compared to what one may want to do today. But it was, people loved it at the time. Really nice. And then we went to our third prototypes, and our third set of prototypes was really for two reasons. The one was we wanted market feedback as quickly as possible. So we wanted people driving these and giving us some feedback. But secondly, we wanted there needed to be a presence out there to keep the momentum going while we went, this amount of engineering and industrialization for this 50,000 would take another 3 or 5 years. And so we needed something there. And there was an interest from some companies to actually buy some of our prototypes and put their branding on and, use it to, showcase themselves and Optimal Energy. And so, yeah, we partnered with High-Tech Automotive in Port Elizabeth, and they would help us to actually make real high-quality drivable prototypes. So it used our battery system and electric motor, and this is our team. These are all our people actually fitting out the steel pipe and fiberglass system, cars with with our systems.
So were you retrofitting then the drive system into an existing body? Were you building?
No, completely new body.
Okay.
Still a completely new body. And we some of the suspension components and stuff were sort of parts from other cars. But the actual body itself was completely new. But it it was not designed with the end in mind. It was designed specifically for this purpose.
Yeah.
And it just had to look the same and function the same, but the what was under the skin was not that important.
Okay.
And so this is at the high-tech assembly line. We built 4 in the end, and it was useful also to teach some of our engineers things like Kanban practices, and how automotive assembly is done, and working with some of the suppliers. And so what you see in front here is one of our battery packs. There were 2 modules per car, and this is just one of those modules that was parked there.
Was the battery pack replaceable? Could you take it out and put a new one in?
Yes.
Okay.
So that was sort of one of our design drivers as well. It wasn't clear to us where the world was going with this, whether, to be, because charging has to be slower because A, the technology, but B, you don't want the lights to dim every time you plug it in.
Yeah.
And it's a huge amount of electricity that you're pumping into this. And as an engineer, I feel very sorry doing that, because I know you're actually hurting this battery, and you need thicker wires, bigger connectors. It just is not an elegant solution. So we actually worked with an Israeli company called Better Place that were developing battery swapping technology. So they'd been working with Nissan and Renault, and had a whole fleet of taxis in Tokyo that were battery swapping.
Okay.
And they built the battery swapping station, and you just go there, and then within 3 minutes you drive away with a fresh battery.
Wow.
And I still think there's scope for that.
Yeah.
And yeah, so we were wanting to work with them and be able to do that as well.
I've seen that applied relatively successfully in India with the tuk-tuks. They have a battery swapping for the electric tuk-tuks.
Yeah. And I know for motorbikes, people often do that. And I think wherever you have fleet vehicles, it's definitely the way to go. So yeah, but we'll see where it goes. And then so we ended up with 4 PEV prototypes. We called them PEV. This is in front of the high-tech offices in Port Elizabeth. They were lovely little cars. We did a lot of testing on them around in our Cape Town area. We also had other vehicles, which were mule vehicles, where we would put in our battery with our electric drivetrain for specific, more technical tests, where we could put more instrumentation on and change the weight and change things to actually get more technical data. These were the pretty ones that we didn't want to mess with.
Yeah.
From an engineering perspective. Yeah, so we also in our planning looked at, as I said earlier, logistics. And so this is just a picture out of our business plan of how we were planning to distribute. We would use ro-ro ships from East London Harbour, taking to Antwerp and Zeebrugge, and from there go to Southampton for the UK distribution, and then other points for the European distribution. Because people don't always realize, I think, how far advanced we were in this process, and that our costing was way beyond an engineering program at this stage.
Yeah. I mean, this is quite, I didn't realize that you guys had mapped out the routes and identified the real market opportunities. You guys knew how many charges there were in the UK, £5,000 incentive per car. I mean,
yes.
Wow.
Yeah, so we'd worked with partners like DB Schenker to do the logistics planning, and came up with so in our business plans, the cost of actually getting a car there was real. It came from people that did that every day. So yeah, and then by early 2011, those PEVs were there, and Car Magazine approached us to run a story on it, and they took 2 of these PEV cars from Cape Town to Hermanus and drove them on the nice curvy roads. And
okay, yeah, I printed the picture behind me here.
I see it. Yes,
I remember that article. I bought that, and that's when we still used to buy magazines.
Yes, that's when we still used to buy magazines. So yeah, so it was a very nice article, and at that stage, the writing was already on the wall. And what maybe I should sort of transition to the sadder part of the story.
Yeah. So what year was that? I'm just trying to. I don't know if it's.
That was April 2011.
April 2011. Okay.
Yeah. So I mean, if people really want the sort of real insides of the story, they're going to have to buy the book.
Yeah, of course. Please, you should buy the book. I've set it aside. Thank you for sending it to me for my December switch off and read the book.
Yeah, no, once you've read it, we may have to have another discussion.
Okay.
But yeah, so but in short, the 9 billion price tag frightened people.
Yeah.
And there was a lot of pushback to say, hey, can't you just take your electric motor and retrofit Volkswagen Golf ones? And we said, but that's not the business. If you retrofit a Volkswagen Golf 1, it's still a Volkswagen. You're just supplying some technology. That's not a business. You're not going to convince people to buy this car. You may sell a couple of hundred if you're lucky. We want to make a big impact in the industry and do something for South Africa. And what I didn't mention was, in terms of our business planning, we would have created around about 10,000 jobs.
Wow.
That included indirect jobs, but it's significant. And that would have been with the first model. And that was fairly conservative. If you really start localizing more of the supply chain and stuff, it's really big.
Yeah, and in hindsight, 50,000 is probably an underestimate of what the market could have been.
Yeah, the market was a bit slow in the uptake, slower than we anticipated, because of many reasons. But I think we would have done it. I think definitely. So that was the one concern. The IDC, had lost a lot of money with the pebble bed reactor because the pebble bed they were the main funder for that, and then the government cancelled.
Yeah.
When President Zuma came into power, and they said to us, never again. So they, after they'd stopped our private funding, said to us, unless government actually comes in and provides some very clear direct funding, they're not going to put more money on the table.
So as a result of government cancelling Pebble Bed, the IDC had a big loss, basically.
Had a big loss, yes. Yeah, they lost several 100 million rand as a result of that.
And now we wish we had that.
Absolutely. It's the same story.
Yeah,
it's the same story. Because these are strategic things which you have to invest, and then you have to believe that you'll get it back because you can see that that's the way the world is going. So it was clear to us, electric vehicles are going to be the next big thing. But even within the IDC, there was a lot of skepticism. And then the other thing that happened is Innovation Fund became TIA, and they became our government representative shareholder. And TIA is a very different organization, much more political. Joule, the Optimal Energy, was not invented here. It came from before the new Exco, and they just felt, that they didn't feel comfortable with where it was going. They wanted rather to support the local, the existing automotive industry, to localize their technologies and not compete with them. And one never knows what all the sort of behind the scenes things were. We later the TIA CEO was actually fired, and he was found guilty of corruption, and the CFO. Whether or not it had anything to do with this, I wouldn't know.
Yeah.
But there's a parliamentary report that I provide a link for in the book, that reports this. So this is out there in the public.
Wow.
But we had these challenges with our shareholders. where they just wanted to stop. And then, the IDC gave us a way out. They said, if you actually can get a big OEM to partner with and basically take over the company, then, we may carry on supporting you. And so we went on a road trip, which the government helped fund and set up, to China, India, and South Korea, meeting up with all their major OEMs, presenting the Joule to them. And it's a hard one. I mean, maybe let me just take a step back, because people will ask, why not Europe? If you speak, to the big European OEMs, those that are present in South Africa, their R&D is all close to home.
Yep.
And they realize, electric vehicles is a big new thing. They need to understand that technology. They're not going to contract this company on the southern tip of Africa to do, this car for them. And so that's why we felt, okay, maybe in the East there's an opportunity. What we found in China was their domestic market was growing so quickly in the electric vehicle domestic market and in other areas. They had absolutely no interest at that time of expanding to the West. And we felt the only leverage we had was to say, hey, the Joule is a car that would meet European performance requirements and safety requirements and stuff. And they weren't present in Europe yet with their cars.
Yeah.
They were struggling to meet those.
Probably would have been easier to sell a South African car to Europe than a Chinese car today.
Yeah.
Because of the perception attached to it.
Perceptions, the perceptions. And in India, we found, in China, they also said to us, do you want to sell our cars?
Yeah.
They, that's what they wanted. And they would invest, but then, in any business we do, selling their cars, but they would want, obviously the controlling share and all of that. We had very good rapport with Tata. They were quite keen to work with us, and we actually had quite a few meetings back and forth. They had been trying to get into Europe. I'd actually driven in one of the electric vehicle conversions in the UK. They were working with Warwick University there. And we realized they didn't quite get the European mindset of what needs to be in a car. And I think they recognized that Joule had some of that sparkle that they required. But a marriage like that takes time. And we actually ran out of time before the Tata relationship could mature. And the IDC had given us a date. They said, if you don't actually have the partner and the government funding by this date, we're not going to fund you anymore. Wow. And then very close to the end, they gave us a last lifeline. They said, well, come up with an alternative plan. Completely alternative. I mean, we presented many alternatives in the journey to get there. But a completely scaled down plan. And they were thinking, retrofit buckies with electric motors type thing. And we felt that's not something we would be willing to do. But we did engage with bus manufacturers. So we spoke to Busmark, and we got a letter from in the city of Cape Town that were wanting to buy more My City buses and were wanting them electric, and would and Ria Vaya as well in Durban. And we put a business plan together for 280,000 million rand that would help working with Busmark to develop a South African bus, plus to retrofit one of the existing buses with electric, but also come up with a bit of a bigger bus that was more suitable for the My City type application. And then the IDC said to us, oh no, we don't think this will work. And they didn't fund it. But they'd already made up their minds. Retrospectively, I think they definitely regret that. But then we closed down the company.
Yeah. When I heard that, my friend, he was obviously he was there when it shut down, and obviously felt for him losing a job, but the yeah the I was more attracted to the engineering side of things, and to see that like not materialize into something that is successful was disheartening. I mean, for me, completely on the outside, I can only imagine the emotions that you guys are going through.
Yeah. Yeah, no, it was very tough. I think there was a lot of anger, and it took me 13 years to write the book. A lot of forgiveness involved
Yeah.
along the journey. Um, and yeah, we had to work through it because I mean, there were some uh, less nice things that happened along the way. We were accused of different, things, um, and that I deal with in the book. But the one
Okay.
thing I'm very grateful for is, as part of closing the company, the IDC did fund the severance packages for all the staff.
Okay.
And so, that cost them quite a bit of sort of extra money. They could have just, allowed us
Yeah.
to be bankrupt in a bad way, but we could settle our debts, and actually close the company in an orderly way. And I
Yeah.
think, that's also what, I guess, we really didn't want, under those circumstances, then to leave a sour taste out there. And that's why there was a bit of a media release just saying we've closed, but we didn't want to, create a big stir and anger out of this, because we knew that the public would be quite angry if they
Yeah.
knew everything.
And I think the cars were donated to UILIO and at the Nelson Mandela University, right?
That's right, yes. So um, the last sort of sets of funding we got was a loan from IDC, and so they were our creditors. So basically everything belonged to them,
Yeah.
and then they sold it to TIA for R1,
Okay.
and then TIA passed it on to UILO. Some of the jigs and the tools and stuff, we were told basically just to destroy it. And it was mostly the paper and the prototypes,
Wow.
that were, and they were never going to do electric vehicle development or whatever. It was,
Yeah.
for research and whatever.
Really sad story for sure. But let me take you back a couple of years to when you were a young guy in school. And maybe I really would like to get your journey to get to the point where you got into optimal energy, and then we could chat about after optimal energy as well. But in the context of a young engineer that is passionate about technology, that really, wants to do something and make a difference in the tech space, kind of what was it when you were a young boy in school that that enabled you to do some of these amazing, crazy things? And what advice, as you talk through your journey, what advice would you give people as they start their journey?
Yeah, this is a fantastic question. So I was born on a farm in Zimbabwe,
Okay.
and well, I wasn't born on the farm, but I was raised on the farm. Um, And in those days, there were sanctions against Rhodesia.
Mm.
And so I just saw the way that my father ran the farm. And necessity is the mother of invention.
Yep.
So he would modify his own farming equipment or make it, and, make, if an engine of a tractor broke, he would do welding or take it in and have parts made at the little workshop in town and whatever. And nothing was ever considered impossible or too complicated. You just had to
Yeah.
do it. It was survival. And before I even knew what an engineer was, I decided I had to be one, or become one day. And part of that inspiration came from a teacher at school. And yeah, so any teachers listening, I think you have an amazing impact on children. So when I was in what was then Form 1, this teacher started a science club at school where you could go after school and play with chemicals and stuff and do experiments. Then he also started an electronics club on a Monday and a photographic club. And I was in all three of those clubs. And I hadn't done so well at school, at junior school. But then when I got to high school, with this real interest being stimulated, I did very well. And, you know, in the electronics club, he would buy old radios and allow us to strip the parts. And then he gave us little circuit books, and we could, you know, make little machines that made funny noises or shocked people or whatever. And I have a few shocking stories that I could tell you. But yeah, on the farm as well, you know, I would go back and I told my father, you know, we had poachers on the farm. I told him, you know, I want to make this radio controlled tank with a camera and that whatever that we can send down there into the bush and to catch the poachers, you know. And I even bought some electronic components to make this, but I had no idea what I was doing. And so I had the privilege of then studying at the University of Pretoria. Yeah, it was amazing to learn how to actually do engineering, and always sort of interested in not just a narrow field, but in some breadth associated with that. My sort of advice I got at school when it came to careers was microbiology, become a pastor, or become an engineer. Quite very different things. Just don't become an accountant. That was
okay.
Yeah, so I had a bursary from South African breweries. So I worked in the as an automation engineer at first, expanding the Roseland Brewery, which was then the biggest brewery in South Africa, or becoming the biggest brewery in Southern Africa.
What year was that, more or less?
That was 1985.
Okay.
And yeah, so I was sort of a white collar worker, managing consultants and contractors, you know, doing the construction work and whatever, and not really doing this nice engineering that I was planning to do. And
writing
so,
RFQs for other people to do the interesting stuff.
Exactly. You know, inspecting contractors that had, you know, not done the work they said they'd done. But I learned so much about people and contracts management and corporate processes and the value behind these things. You know, so then I went to work for a defense company called what was then Kentron, which was a division of Denel, that did missiles and weapon systems, and felt like, now I'm going to do some real engineering. Except they felt I've done so much of this stuff, I had to become a contracts manager on one of the contracts.
Okay.
And then I spoke to my boss and I said, no, but I want to do technical stuff. And so he said, okay, well, we can try it. You know, you're going to sort of be demoted in position. And, you know, you can go and work in the software department, which is where I wanted to go. And then I did well enough there that I sort of worked my way up the ranks, did project management. And, you know, in an environment like that, the thing that makes it tick is systems engineering. It's how you do the engineering on these multi-massive projects, you know. So I did systems engineering, project management, and then later, you know, was an engineering manager. And my passion was, you know, doing this complicated stuff. I felt I had a gift to see where there's chaos. I can identify, but there's a relationship between this, and these things somehow can work together or connect together. And when it comes to, you know, understanding user requirements, when it comes to system A and system B that need to work together, or in tests when we, you know, shot missiles or whatever, to be able to relate what I'm seeing to the data, whatever, you know.
Are you dyslexic by any chance?
Not that I know of.
Okay.
And you know, I also learned, you know, to love people. You know, my parents were both, you know, sort of real Bible believing Christians and taught me from a young age that loving people is what you do, and that's how you honor God. And for me, that was really just part of the journey. And I'm not necessarily very good at that. I'm not, I'm not the best extrovert out there, but I consider people important. So, I then at some stage felt I wanted to move out of the defense and stop making things that can kill people. I'd had the privilege of going to the Hong Kong International Airport to be part of the construction team there for a while, doing integration of big systems. And then the opportunity came to be part of the SALT team. And I was interviewed to be the the systems engineer for that project. And it came about because I wanted to move from Gauteng to Cape Town.
Okay. Maybe what is SALT for those that don't know?
Oh, yes. So SALT is the Southern African Large Telescope. So when we constructed it near Sutherland, it was the biggest optical telescope in the Southern Hemisphere. So it's extremely challenging from a design perspective because the optics have to be so precise and they have to remain precise regardless of where you're pointing with the telescope and what the temperature is. And, most things would expand or contract as the temperature changes. And so, you're talking nanometers of alignment between mechanical systems and things,
wow.
And that you have to control systems that have to control to that level of precision. Anyway, so at the end of SALT, that's when we said, okay, what next?
Let's make a car.
Let's make a car. People often ask me, but what do all these things have in common? How can you do that? I love learning new things. So at the moment, and I know we'll go there, but I'm working on the Square Kilometre Radio Telescope Array, which is completely different to an optical telescope and obviously completely different to cars. But I enjoy that journey of learning, about the new technologies. But then what I bring to the table is this system engineering understanding, being able to, connect these dots. And then, I learned also through the optimal energy process how to even take that into the business environment, into the marketing environment, into intellectual property, into whatever. So I'm a jack of all trades, and I like to think I'm a master of maybe one or two things, but not many.
No, I think you definitely are, and I think experience counts for a lot. That experience is a master in itself. Having been there, made a lot of mistakes, and acknowledging the mistake and actually learning from that. I'm sure you've had many interviews, right? Interviewing engineers for the many teams that you've run. How do you distinguish in a couple of hours, if even, like and you get different traits. So you have people that can go really deep and write some software and they like thrive in that really deep, narrow focus. And you have people that are looking at the broader picture. And maybe some people that shouldn't have studied engineering, they should have done accounting for that matter. How do you, like in your interview process, because I find that's one of the hardest things that I sit across the table from somebody, not judging the personalities or anything, but how do you fit them into the right place inside an organization? Because there's different skills required depending on and how do you kind of tease that out inside a 45-minute or an hour meeting?
Sure. Yeah. Now I find that particularly hard. So I rely a lot on my colleagues, the wisdom of crowds, to do that. And there's some things which I can pick up on, but then I've learned what my colleagues know or don't know, or what they pick up so with Optimal Energy, that year that we appointed many people, around about 500 interviews in 1 year.
That's a lot.
And I didn't really consider myself a good judge at that stage. I always deferred a lot back to Jan and Kobus, because I like to believe the best in people, So I think since working at SKA, I've not done that many interviews, but it's interestingly been a phase in my life where I've really learned a lot more about people and learned to engage more with people. SKA is a multinational organization where we have 16 different partner countries, and it's the countries that are the partners, not organizations from those countries. And so you deal. I say to people, I'm a diplomat. I'm not an engineer. And I've learned so much about working through influence versus control. But anyway, to get back to your question, a wise person once said to me, you appoint for character and you develop skill. And I think often we do it the other way around. We say, hey, this person has this amazing CV, But if their character is doubtful, they may not fit into your team, they may not fit into your culture. And they may even end up stealing from you if they're that doubtful. So I use doubtful in a qualified sense here. But you need that teamwork. And I was looking at your video a bit earlier about your organization and just seeing the four of you. And obviously you've had your own stories around that, but the trust and the working at that very top level is so essential. And we discovered that at Optimal Energy as well. One of the tools, that I've used, not recently, but that I've really felt very useful is called Belbin profiling. And what Belbin does is they categorize you, you do a bit of psychometric tests, and some of your colleagues do the same, but they categorize you into 9 different categories of team engagement. So they say you normally up to 3 of these roles you could fulfill. One person could be the planter, that's the person that comes up with ideas. There's the finisher, which is the person that's good at the end. There's the person with the whip that is really chasing people down. There's a coordinator. There's a resource finder. That's the person that you ask him, where can I find tires? That doesn't even have to open his cell phone number. He said, oh yeah, you need to speak to Mick. He's the tire guy. And so I don't remember all the others. But you actually do need all of these types on your team. And that's over and above the personality angle, depending on, of course, what it is that your team is supposed to do. But sometimes we miss that, the person you're talking to is a planter, and that's why they never finish the job. But they've got all these brilliant ideas, and if you don't use that person for what they were created for, then, you miss it.
I'm just thinking through my 3 other partners and trying to, I think the one thing that does make us work is that we're certainly not the same. Probably, if anyone could be a fly on the wall, you'll see the fights that we have, because I think our characters prioritize different things, but collectively that's what we are potentially prioritizing all of it because of the collective. But individually, it's you can't do it alone for sure.
If you do anything big, you need to be able to work with others and use their strengths. And I'm not afraid to appoint somebody that's better than me.
I fortunately, that was one of my gifts, was to realize that I'm not the sharpest in the room, and I'm completely fine with that. And having the sharpest people around me is far more important to me than anything else. I was going to ask a little bit more about the Square Kilometre Array. Maybe just again, what is that? And it's obviously a country project. And what is the objective? Like, what are we trying to achieve with that?
So I mean, scientists are always asking questions, and in this case, it's a subset of the standard astronomical things. Where does the universe come from, and Is there life out there? 20 years ago, a scientist would have been ostracized if they asked that, but today that's fashionable. And a lot of what we learn in physics and that we apply in engineering was originally discovered as part of even astronomy, because there they have these extraordinary science experiments happening 24/7 out there. And if you can get as much information as you can about this 10,000 degrees Celsius explosion that's happening there, you may learn a couple of things. But that's probably not enough for country to invest billions in to make it happen. The other sort of benefit of this type of project is the technology that's developed. So CCD cameras that we're using in this interview was developed. They were developed as part of astronomical projects to observe stars initially. That's where this technology comes from. And then later that was commercialized and color added and a couple of other things. Wi-Fi. And we can carry on. So there are spin-outs that come from this, and that's why these 16 countries, they don't just want to give money and we spend it. They each want a segment of the work that they can spend that money in their own industry and actually develop things that are really cutting-edge technology. Because what you do on a science project like this is you try and make it bigger and better.
Yeah.
So this will be the biggest telescope in the world when it's completed in 2030. And that means it can look at even fainter objects out there. And the difference between a radio telescope and an optical telescope works with light. So that's visible. We understand that, and you can make nice pictures from that. And, we're all aware of the concept of a pixel. And each pixel is a little detector that could say, yes, I've received this wavelength of light coming in. Radio telescopes look at wavelengths of light that we cannot see, a lot lower frequencies. But the stars and the gases between the stars are also emitting radio waves.
Okay.
And if you take your radio off the station, you hear a hissing sound. That's because of the microwave background and other sort of noise that's out there. So what that gives us additional information that the optical telescopes doesn't give us. And so you can develop the physics models for the stars and whatever further. It's obviously very different technologies that have to be developed. So the SKA, Square Kilometre Array, is sort of a very ambitious project to build a square kilometre of collecting area of telescopes. So with that, you can catch a lot of radio waves. And in this, but we're not doing that all at once because that's very expensive and ambitious. So we're sort of in phase one. And what we're doing now is building two different telescopes, one in South Africa, which comprises 197 dishes.
Oh, wow.
Each 15 meters in diameter.
Oh, my word.
And one in Australia, which has sort of, it looks almost like the old-fashioned television aerials with the little wires going across them like this.
Yeah.
Except this is like a Christmas tree and about the size of about 2 meters tall Christmas tree with, so 135,000 of those.
Oh, wow.
In the Australian desert. And they are arranged in spirals. So the dishes here in South Africa, let me maybe just focus on that. There's a core where there's a whole lot of them, and then the spirals that go out sort of 70 kilometers from the center, so that the end to end is about 150 kilometers.
Wow.
Between the furthest dishes.
So how many dishes are there in South Africa again?
197.
Wow. Okay.
And so this is being constructed near Carnarvon, which is in the Northern Cape, in the middle of nowhere. And the reason for that is we don't want any other radio waves there. So no cell phone towers. No, the farmers aren't allowed radios. And on the site, no electronic equipment that is not in a shielded compartment, which is where our computing and stuff lives underground in a metal chamber that keeps all the radio waves in so that the dishes don't actually pick it up.
Yeah.
You can't go there with a petrol car because a petrol car has got spark plugs and go tick, 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 and it picks it up. If your car has got Bluetooth, it's got to be removed, surgically removed from the car before you're allowed on site, your diesel car now. All the electronics has got to be off. I'm not allowed to take my smart watch because it's got electronics on, and the CPU on this, makes a noise. And so it's a very radio quiet site. And so people may have heard of the Meerkat telescope.
Yeah.
So the Meerkat was built as a precursor to the SKA. So that was part of South Africa's contribution to the SKA, saying we will build 64 dishes. It was supposed to be 16 initially, but then that grew to 64 because South Africa was very ambitious. And that's part of the 97. And we're sort of co-located. So Meerkat is operational. It's presently the most sensitive radio telescope of that type in the world. And so we'll be upgrading that to 197 with bigger dishes as well. So it's not just the same as Meerkat. And the data from each dish goes, it gets digitized onto optical fiber. That optical fiber then runs to what we call a central processing facility, which is on site, near this core of all the dishes.
Yeah.
And that building is buried underground. And, as I said, it's steel containers, and all that's allowed out of there is optical fiber plus power going in. And then the data from there goes all the way back to Cape Town. So we put in optical fibers all the way from Cape Town. And our internet, or our connection there, is around about 20 terabits per second.
Oh, my word.
It's sort of a couple of thousand times faster than your internet.
No problem watching a YouTube video there.
Yeah. So that data then goes to our so-called correlator, which will be built here in Cape Town. And that takes then the data from the 197 dishes, and it looks for the common themes between these dishes, because they're all pointing at the same object. And if you process the same data from different positions, you actually get more information. You can somehow point more accurately, and you can do a lot of clever things. And that's then basically what we do. And each of those dishes then basically give us a pixel, which doesn't sound like much.
Yeah.
Then with time, as the sky rotates, you can even make very pretty images and add that to what the optical things are. And then there's lots of other science that you do, which is not image related, with the system. And then from there, we need to get the data sent to all our partners across the world. So they have, each partner country or region has their own supercomputing systems, because there's a huge amount of data that they then receive, and then they do the final processing on. We don't do all the processing in Cape Town.
And anything interesting discovered from the Meerkat or?
Yes. Yeah, no, there's a lot of different theories that have been debunked and new things discovered with the Meerkat. Not being an astronomer myself, it's hard for me to point too many things. But the one very interesting thing is the center of our galaxy has a so-called black hole. Now, black hole is so heavy that the light can't escape.
Yeah.
But it could create images of the center of our galaxy, and to a lot more detail than was ever visible before. And previously it was just fuzzy blobs, and now you can see some of them are dots, some of them are blobs. But interestingly, there are lots of lines. There are what look like ribbons of gas or material or something there that people had never known was there before. And
Very
that was,
interesting.
as a result of the meerkat. Now, the implication of that, I wouldn't understand.
Yeah.
But that picture is proudly displayed all over the meerkat offices where I'm working this week.
Okay, awesome. Um, yeah, that's an amazing journey. So maybe just we've been now talking for like almost an hour and a half now. As a closing question, just going back to the Optimal Energy Joule story, like what do you think you do different, if any?
Yeah. I think I would approach the funding and the commercialization a bit differently. Um, we trusted our funders and our board. We wanted a more commercial board, and unfortunately, government appointments make it a bit more like the SABC board or the ESCOM board. And we wanted automotive names there.
Mm.
But yet, we had to work within that framework. And so I would have pushed harder initially that we do things in a more commercial sense. I may have not even taken the government money, or at least pushed back at those early days. And, we didn't really push back hard. We were just so glad to receive the funding. So that's, I think, one thing that I would do different. But also, the big jump to 50,000, we became convinced that we had to make that jump quite quickly to stay ahead of the automotive industry. Now, retrospectively, they've been quite slow to adapt, and we would have had more time than we imagined.
Yeah.
But if we'd grown a bit more organically and actually, those PEV cars, we'd taken them maybe a step further and sold 1,000, 2,000, and had sales on our books.
Yeah.
I think investors and even government and the IDC would have looked at us a bit differently. Because they were still asking very fundamental questions, but we were so convinced, and especially from the market feedback we were getting and everything, and from our consultants that were working with other automotive companies and even EDAG in Germany. They were the people that were in the automotive and in the know, were so convinced this is the right thing, and we need to do this timing wise. But our funders didn't quite get that. But if we had gone that little bit slower, I think that may have made a difference.
Yeah.
But there's politics behind the scenes. There are
Of
other
course.
things behind the scenes which you never know whether anything could have been different.
Yeah. And then also just two more last questions is ever approach Elon Musk? This is obviously thinking back to 2008 when he was also, I think the Roadster was released by that point in time, but the Model S was far from being
right.
released.
I asked Kobus at one stage to do that because I felt that there's an obvious synergy, but the reality is with that type of person, and I may be mistaken, but I think somebody sent an email or something, I'm not sure. But the reality is they get so many approaches.
Yeah.
And that it's not really realistic. Some of the people that we did engage with, we engaged with some fairly high profile people in South Africa, even outside government. It's a hard sell when you've not got everything in place yet, and you need sort of people with a real investor mindset to be able to look at the business plan, to connect the dots, to say, yes, this is solid, let's back it.
Yeah.
Just speaking to a guy with a lot of money, with many options to invest it in the stock exchange or anywhere, is not really going to help.
Yeah. And then finally, in closing, you've, as you said, after a good couple of years and some soul searching, you put pen to paper and wrote your book. What inspired the book? There's a picture of it here.
Yeah. Yeah, well, maybe I should start with the title.
Yeah.
Being Hope Arising. My first title was Who Killed the Joule electric car? And that was still while I was, experiencing some of the frustration and whatever out of it. And it's been quite a spiritual journey to get that healing and to realize, it's very easy to point fingers. But, most often people have good intentions.
Yeah.
I quote Hanlon's razor, which I'd never actually Googled the term, but and basically which says, don't ascribe to malice or, badness, anything that could better be explained by stupidity.
Yep.
Now, I didn't really want to call people stupid, but people came with good intentions, but we were working with real people, individuals in government and elsewhere. And I just realized there's still so much goodwill out there, and so much potential in South Africa today. People that are qualified, that can do complicated things like this. And yet, economically, South Africa is going backwards. We are becoming a technology consumer. We're not really producing more and more technology. Mechanical engineer studying at university, learns all of these very complex things, but many of them may end up designing water tanks, and working for a company that makes little low-tech widgets, which is below what they could be doing. And I'm not trying to belittle, that
Yep.
type of work, but to do that stuff takes vision. It takes systems in the country because a lot of that funding is hard, in DST speak. And I mean, I learned this from DST documentation years ago. But they do speak of the innovation chasm when people just don't understand to get from that prototype to actually having a factory producing these things and selling them is a huge step.
Yep.
And there's a huge amount of engineering, but we can do that. We have the people. I mean, your company, I think, is a wonderful example of how South African engineering can really get into that world class of doing things. And if we can somehow promote that and facilitate it in training at universities better, how to do these complex things, facilitate it in our funding systems, facilitate it in people's mindsets that don't quickly say, oh no, that's not possible, let's just import it. Plus in government spending, the one thing that really is hard for me to stomach is these international IPPs, the
Power producers.
Independent power producing programs. They should be forcing those companies to work with a local company that localizes, those things. Now, there are localization requirements, I know that. But I know of companies in South Africa that do similar things that just don't ever have opportunities to work with these big guys. And I don't see that Eskom and others are using the strategic benefit that they have of spending government millions to actually promote South African industry and not just achieve, their primary end goal to generate electricity.
I certainly agree with you, and I don't know if I should open that can of worms because we experience the same thing, but it's unfortunate. I think if I were to add my 2 cents to it, is I think that there's we've lost patience in nurturing the creation to fruition. People want quick wins, and
Yes.
it's hard. You go through that typical hype cycle, right? So you have the hype, you make the first prototype, first 4 prototypes in your case, then there's always a long dip, and you have to see out the time until you actually see the benefit. But
Yeah.
people are don't have the appetite and they're impatient. They want quick wins. And so I think the way, and we've lost this ability to create something.
Yeah.
We'd rather just buy it quickly from someone else. And that really irks me. It's I think any successful company or successful country is based on the ability to go from creation to value creation, not
Yeah.
importing it from somewhere else and then thinking that you've created something you haven't.
Yeah. Yeah.
And so yeah, it's obviously true to our heart at our company that we want to keep creating. We've had so many failures and we've like seen the wall so many times. We've seen the train coming towards us a couple of times, and in uncertain times that we are at the moment, like it's tough to kind of see it through. But I think that the passion has to be there to create, and to create you gotta fight. There's no
Yeah.
easy way. So
Absolutely.
I agree with you. We create the right engineers. We've got the skills, but that step after that, the funding, the ability to fund, and the ability to see it through, is I don't know. I think maybe it's a function of social media where we want to just swipe every 7 seconds, and so you want
Yeah.
creation to happen every 7 seconds, but physics doesn't happen like that.
Yeah, I think it's something that, government also needs to step in, because they set the tone in a sense.
Yeah.
When we went for our battery visit to China, what we came across there was China has these, I can't remember if it's a 5-year program or a 10-year program, where they create a theme and they fund it for X years, and there's certain objectives in that time. And the company we met with, Thunder Sky, they had started up under one of these schemes, and they had developed batteries. They had then put them in an electric bus, and they took us for a drive in this electric bus. And they'd been selling some of these batteries all over the world. They were in Swedish submarines and I don't know wherever, the very big batteries. And then those multi-year programs, extend beyond the next election. And they create this long-term vision. And, flowing from that, there had to be a certain number of electric vehicles sold in every province in China. They actually had those targets. Yeah. They said to them, you need to put up the factory, and they facilitated this momentum with the technology on the one hand, but also, with the market. And today, as BYD is moving into Europe at such a pace.
Yeah.
And it's, yeah.
But that's where I think let's call it the communist government with a capitalist mindset can play a role, because they think 20, 30 years and they commit to it. Whereas as you described, when President Zuma came into power, the Pebble Bed reactor funding stopped. That was a political decision, which is completely the wrong decision. And so because you have this turnover of leadership, it's a quick win. You've got 4 years to make your thing, and you've got to do it as quick as possible. And then that trickles down. The funding is the quickest way. Who cares if it's bankrupt after 6 years? During my 4 or 5 years, it was fine. It's very frustrating, to be honest. I think the reason why America remains innovative is they've got very, very strong VCs that fund that innovation. Absolutely. I don't think it comes from the government at all. Obviously, they have a strong stock market, and they have a VC culture. We don't have that.
There's enough money running around. In South Africa, money is scarce,
Yeah.
Living in the UK now, if I put my money in the bank, I may get 3%.
Yeah.
And so they look to other places to put their money, and they would take more risks if they can get a bigger growth.
You mentioned that you put pen to paper. Where can we get the book?
So I have a website. It's joulebook.co.za. Joule is Joule. And it's also available in most of the bookshops in South Africa. I know Exclusive Books keeps it on. And then it's available on Amazon, but not amazon.co.za. If you're outside the country, then you can go to amazon.com and they'll print on demand.
We'll put those details up and also in the comments on YouTube.
That's great.
Ray was asking me, what car do you drive now?
Let me show you. Maybe you want to also. So that's a Renault Zoe.
Okay.
So it's also electric. I've been driving an electric since 2017 when I moved to the UK.
Okay.
So I chose a car that was the closest to the Joule that I could find. And it also happened to be the car of the year in 2015, I think, in Europe. And so this is my third one. I always buy them secondhand, but this is now sort of, every time it's a bit nicer.
Yeah.
This is a 2023 model. And this is in front of our headquarters in the UK.
Okay.
And this is sort of one of the radio dishes that are on site. This is not one of ours.
Yeah.
This also happens to be a radio telescope site.
Awesome.
So, yeah.
That's cool. Gerhard, thanks a lot. It was a fantastic conversation. I love chatting to people like yourself. I just gain so much from that. In awe of you being able to build the car that you built. It's really an honor to have you. Thank you very much.
No, thank you, Yanesh. I really appreciate it. And the way you conduct the conversation is great. And I really appreciate the opportunity. And all the best for you guys. I mean, I really, I think you're doing things very well, obviously, considering the success. But I also like the ethos of your company, and how you see yourselves fitting in and what you're wanting to achieve. And so, all the best with that.
Thanks, Gerhard. Next time you're in PE, please give us a shout. We can visit high tech together and look at the cars.
Yeah, I'd love to do that. Great.
Thanks, Gerhard. Have a good day.
Cheers, Ray.
Cheers, Gerhard.
Bye.
Bye.